So question 15 talks about parts per million. So I really want to think about if it's 1 part per million, it's 1 millionth of that is the actual substance, and it's all per million. So ppm it's abbreviated as, and you'll come across this a lot in maybe pharmacology or certain situations. So it says the labeling on a tube of toothpaste says it has 0.1% sodium fluoride, and we've been told that it has a molecular weight of 42. So that means we automatically can write that equation that we're very familiar with now, that 1 molar is equal to 42 grams per liter. And we know that as a fact. It says that it has 0.1% weight per volume sodium fluoride. So that's back to our percentage, and you remember our percentage, 1% equals 1 gram per 100 mils. And that means that if it's 0.1%, it's equal to 0.1 grams per 100 mils. Right? So we have a few different things going on here, and we have to make sure we're clear. So let's get everything again per liter. So 0.1% is going to be equal to, that's in 100 mils, so 10 times that would be 1 gram per 1,000 mils. So essentially, can you see that it would be almost 1 part in 1,000 parts, right? So that's 1 in 1,000. So how would that equate if we kind of got it to millions, right? So how can we do that? Well, we can say if we turn to this side, we have to multiply it by 1,000, right? And we multiply this side by 1,000. We now see that in parts per million, there's 1,000 parts per million. So there's 1,000 parts in a million parts, right? So 1,000 parts per million is what we're looking at here with regards to the sodium fluoride. However, we've been told we have to find the amount in parts per million of just the fluoride ion. And it tells us in the question that fluoride has a molecular weight, an atomic weight of 19, and the molecular weight of the whole NaF is 42. So that means that 19/42 would be, if as a fraction, would be the fluoride. So if we get 1,000 divided by 42 multiplied by 19, this should give us the parts per million of the fluoride ion. So if we go here, calculator, and we say 1,000 divided by 42 multiplied by 19, we get an answer of 452.38. But 452.38 parts per million. Okay, so that answers that question, right? So the answer of fluoride would be, if just the fluoride in parts per million, it's 452.38 parts per million. And that's question 15. So if we think of question 16, it should be a bit familiar to us. The molecular weight of urea is 60. So we know already the first thing we're going to write, 1 molar is equal to 60 grams per liter. It tells us that 5 grams was dissolved in 50 mils of water. So 5 grams was put into 50 mils. Let's get everything to liter just so we can equate what it would be. So to get it to liter, we'd multiply 50 by 20 and we'd get 1,000 mils, right? And if we multiply 5 by 20, we get 100 grams. So that's the same, but just in per liter. So what does that equate to be? That's really what we have to work out with regards to the molar situation. So we shrink that a little bit and give us some more space. We now know that 1 molar is equal to the 60 grams per liter. So how many molars is equal to 100 grams? So we know it will be more than 1, because here you had just 60 grams in a liter. In this case here, you had 60 grams in a liter, where now we're actually going to have 100, which is more per liter. So that means that we should be able to, even our heads work out, it's going to be higher than a 1 molar. So 1 molar equals 60 grams per liter. How many molar is equal to 100 grams per liter? So again, I'm going to do the same trick that I've been talking about throughout the tutorials. I'm going to do the same thing to each side of the equal sign, and I'm going to get the 1 divided by 60 multiplied by 100, and I get 1.67 molar is equal to 100 grams per litre. So now I know the solution that was made up is 1.67 molar. But the question says that 10 mils was added to 50 mils of water. So we have to be very careful here. If you think of a solution that had 50 mils and now you've added 10 mils on top of that, that's going to bring us to a total volume of 60, right? So in that 60, 10 of it is your original solution. So the real question you have to be wary of is, what's the dilution here? Well, essentially it's a 10 in 60 will be your important solution that you're working with, which is the same as a 1 in 6 or a 1 in 6, 1 over 6. So it's a 1 in 6 dilution that we've done. So if we know that it's a 1 in 6 dilution, we can come back to what we know already, that it's 1.67 molar divided by 6. Get the calculator. 1.67 divided by 6 gives us 0.278 molar. And 0.278 molar is now the molarity of the final diluted solution, which was the question we were looking for. We move on to question 17. How many micromoles are dissolved in 2 litres of a 20 millimolar solution? So if it's 20 millimolar, you know that's 20,000 micromolar, which is 20,000 micromoles in a litre. And we've been told that it's 2 litres. So if that's how much is in 1 litre, we must have 40,000 micromoles. So that's the answer. 40,000 micromoles will be present in that 2 litre solution of a 20 millimolar solution. Alright? On to number 18 now. The molecular weight of NaCl is 58. How many milligrams are in 50 micromole of NaCl? So we'll start again with our 1 molar equals 58. It's actually 58.44 grams per litre. That's of NaCl. How many milligrams are in 50 micromole? So let's get it all down to my normal trick I've showed you before, where we go 1 micromolar is equal to 58.44 micrograms in a litre. And it's asking for 50. So if we say 50 micromolar is equal to, now we'll just get a calculator again. We say 58.44 times 50 is 2922 micrograms per litre. And the question said how many how many milligrams are in 50 micromoles. So we have to turn this to milligrams. So we should know already that if this is micro, we need to divide by 1,000. So if we move 1, 2, 3 and put the decimal point in here, it's going to be 2.922 milligrams in that litre. Alright? And that litre was made up at 50 micromolar. So 2.922 milligrams. So that has us up to question 18 completed. We just have 2 more to do, and we'll do that in the last tutorial.